Let's look at a gravitational force problem. These are very simple, and I won't ask you to do much with them other than a straight calculation, but the hardest part is putting them into your calculator correctly because of all the scientific notation. So we are talking about why you can't feel the gravitational pull with everyday objects. You have a mass of 57 kilograms. So we'll say mass 1 is equal to 57. And your friend has a mass of 61 kilograms. And you sit next to each other at a table, 0.51 meters apart. And to give you some perspective, 57 kilograms is equal to about 125 pounds, and 0.51 meters is about 1.75 feet. So these are reasonable numbers for reasonable situations. The equation to calculate the gravitational force between two objects is the gravitational constant times m1 m2 divided by r squared. And our gravitational constant should be 6.673 times 10 to the negative 11 newtons times meters squared divided by kilograms squared. Both of these things right here need to be on your equation card. And remember, I don't care if your equation card is really a card, but you need to have a place to put all this so you're not randomly searching through all the notes trying to find what you need. Just write it in one place and save it, please. So when we plug into this equation, we get this large constant. Actually, it's an incredibly small constant, right? The number is just large to right. Times 57 kilograms times 61 kilograms divided by r squared. And we have to solve what's in the parentheses first. According to our order of operations. So 57 times 61, and then divided by 0.51 squared, gives us like 13,000. And because I can see that I'm going to have two significant figures in my answer, I'm just going to round this at the decimal place. And we see that we'll have kilograms squared divided by meters squared, and look how those cancel out to give us newtons. Now to put this scientific notation into your calculator, you need to find the EE or the exponent button. And if you're not sure how to do the scientific notation in your calculator, please go back and read the page on scientific notation in your notes back in the very early math chapter. And you'll get a very, very, very small number, and please do not give it to me with all those zeros. I will take points off. Write it into scientific notation if it has more than 3 zeros. So if we count to the negative 7th. Now to give you a perspective, 1 Newton is equal to the force it takes for you to take about an apple and lift it up 1 meter. So think about that force, and then think about how small this value is. This is why we cannot feel the force between everyday objects. If we look at our equation, the only way to make these forces large, because this number is very, very, very small, is to make our masses be giant, like our planets, or this radius be very, 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 very small, like the distances between atoms.